Good morning, welcome to day 2 of our MCA review. Today we are going to be doing Pythagorean theorem and exponents. Now we're going to start off with Pythagorean theorem because we haven't learned this before. This is going to be something new. What Pythagorean theorem means is a squared plus b squared equals c squared. This is going to have to deal with triangles, right triangles. So what a squared and b squared are the legs. So this could be a squared and this could be b squared. What c squared is this. It's the longest side. We call that the hypotenuse. Sounds like hippopotamus, but it's hypotenuse. A squared plus b squared equals c squared. So what this means is a squared, we have 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now if we add those up, 9 plus 16 equals 25. So a squared plus b squared equals c squared. C squared is always going to be your hypotenuse, or your longest side. A squared and b squared, they don't matter as long as you have one for each of the legs. So what we're going to do is find the unknown length, and we're going to round to the nearest hundredth if necessary. So we do have their legs. We have our a squared and we have our b squared. We're looking for our c squared. We don't know what our c squared is. So what we're going to have is 18 squared plus 7.5 squared equals c squared. So what we're going to do then is we're going to figure out what 18 squared plus 7.5 squared is. So we can put this into our calculator. 18 times 18 gives us 324. So 324 plus 7.5 times 7.5 gives us 56.25. Now what this is going to give us, if we add it all together, is our c squared. So 324 plus 56.25, that gives us 380.25. Now if we wanted to find what just c was, we would take this 380.25 and we would find the square root of it. So finding the square root of 380.25, again, something you need to put in your calculator. So let me put this in quick. Square root of 380.25 is 19.5. So 19.5 is our c squared. So 19.5 inches. Now you see how we can't just add 18 plus 7.5 and that would give us our answer. This side is not a sum of the two sides. We need to put in the squareds and do the Pythagorean theorem so we can find our last side. Here we have our, let's say our a squared is here and our b squared is here. Oh, hold on, this is our longest side, so this is our c squared. We're looking for our b squared. So what we have is the square root of 6 plus our b squared equals the square root of 15. So these are a squared and b squared. So what we have then is the square root of 6 to the second power is just going to be 6. These will cancel out. So we have 6 plus b squared equals the square root of 15 to the second power. So those cancel out and we're just left with 15. Now how we find this then, because we're going to subtract 6 from both sides. So we get b squared equals 15 minus 6, which is 9. Now our b is not quite by itself yet. So what we need to do is we need to find the square root of this to get rid of our square. So if we find the square root of b squared, that cancels out our 2. We got to find the square root of 9. So b equals the square root of 9, which is 3. So our y here has got to be 3. Alright, our next problem, we are finding the unknown lengths. We don't know what a is, so we're going to have an a squared. We do know what b is 123. So 123 squared. And we do know what c is, so 139.4 squared. Because remember, a squared plus b squared equals c squared. So this will give us our a if we solve this. So what we need to do then is we need to figure out what 123 squared is. So we have a squared plus 123 squared, so 123 times 123 is 15,129. Then we're going to find out what 139.4 squared is. So 139.4 times 139.4 gives us 19,432.36. Alright, so what we need to do now then is we need to get a by itself. So we need to subtract 15,129. Just like any other equation, we're getting something by itself, so we need to get rid of everything else. So subtracting 15,129 over here. What that's going to give us then is, let me put it in my calculator quick, 4,303.36. So we know our a squared equals 4,303.36. Now our last step is to get rid of this square. So we're going to find the square root of it. Find the square root of both sides. So our a is going to come out to be the square root of 4,303.36, which in the end gives us 65.6. So a equals 65.6. That's what our a would be here in this question mark. Alright then, if we're doing a squared plus b squared equals c squared over here, this is what's called the Pythagorean theorem again. What we need to do then is find what a is, which is the square root of 8, plus 1 equals our c squared. Now remember, these have a squared on them, so we can put a squared on a and b. but a square root and a squared are going to cancel each other out, so what we're left with is 8 plus 1 times 1, which is 1, equals c squared. 8 plus 1 gives us 9, equals c squared. Again, we're going to get rid of that squared sign, so we need to find the square root of it. The square root of 9 is 3, so our answer is 3 equals c, so c equals 3 up here. So that's how we would find the unknown lengths using the Pythagorean theorem. Here we are again talking about the Pythagorean theorem, but we are we're going to learn the converse, or the opposite of this statement here. So the theorem says if a triangle is a right triangle, then a squared plus b squared equals c squared. The converse of that, if a squared plus b squared equals c squared, then the triangle is a right triangle. So we just basically flipped these two sayings. So what we need to do is tell whether the following numbers form a right triangle. So what we need to do is figure out if a squared plus b squared equals c squared. We know our biggest number is going to be c squared, so we know that 10 is going to be 10 squared. We also know that 6 and 8 doesn't really matter. They could either be a squared or b squared, but let's just say 6 is a squared and 8 is b squared. What we need to figure out is if 6 squared plus 8 squared equals 10 squared. So 6 squared is 6 times 6, which is 36, plus 8 squared, which is 64, equals 10 squared, which is 100. So if 36 plus 64 equals 100, then we know that this is a right triangle. So 36 plus 64 equals 100. So 100 plus 100, or 100 equals 100, so they're the same thing. We know that this is a right triangle. Here we have our a, which is 10. So a squared is 10 squared, plus our b, which is 12, so 12 squared, equals our c, which is 16 squared, so 16 squared. So 10 squared is 100, 12 squared is 144, and 16 squared is 256. So what we need to figure out is if these two equal 256. So 100 plus 144 is 244. 244 does not equal 256. They're different numbers. So we know that this is not a right triangle. So this one, the first one was a right triangle, the second one was not, because they do not equal. A squared plus b squared does not equal c squared. Last one in Pythagorean theorem is we need to find what x is. So it says, what do we know? Well, we know that this is c squared on this triangle. We know that this could be a squared. And we know that our b squared is going to be here. We also know that this is c squared on this triangle, and this is a squared over here. We are trying to find a squared equals x, we're trying to find x, so we're trying to find the a squared on this triangle. We have the two numbers over here, a squared is 6 and c squared is 12, so what we need to do is find b squared. So what we need to do then first is look at this first little triangle. So 6 squared is a squared plus b squared equals our c squared, which is 12. So to find what b squared is we need to do 36. 6 squared is 36 plus b squared equals 144. To get b by itself, we need to subtract 36 and subtract 36 over here. What we're left with then is b squared equals 144 minus 36, which gives us 108. So to find what b is, we need to then do the square root of 108. And our b then is equal to 10.39. So we know our b is 10.39. Now we know what b squared is and c squared of this triangle, so we can find what a squared is here. So what we're going to do then is find what a squared is, or a. So we know we don't have an a squared. We do have a b squared, which is 10.39 squared equals our c squared, which is 14 squared. Alright, so 10.39 times 10.39 equals 107.95. 14 squared is 196. So a squared plus 107.95 equals 196. Trying to get a by itself. So we subtract 107.95. And then what we're left with, after we get rid of those, is 196 minus 107.95, 88.05. So a squared equals 88.05. Find the square root of that. That's our last step. And a equals 9.38. So we know our x equals 9.38. So the formulas that were helpful here would be a squared plus b squared equals c squared. That's our Pythagorean theorem. And we knew what a squared and c squared were here, and we knew that c squared here on this triangle is 14. So that helped us find our answer, which was 9.38. Alright, now we are going back into exponents. So, exponents, like we talked about a couple of weeks ago or a couple of days ago, here we have a multiplication, so it's like we're going to add our exponents. So 3 plus 5 then is 8, so 7 to the 8th power. Another way to do that is to make our table. This is saying we have 3 7s, so we can write 7 out 3 times. This is saying we have 5 7s, so we can write out 7 5 times. If we count them up, 1, 2, 3, 4, 5, 6, 7, 8, we have 7 to the 8th power. Here, if we make our table, we have 4 x's, so x 4 times, and x 3 times. So 1, 2, 3, 4, 5, 6, 7. Our answer is x to the 7th power. Now if these two are touching, that means multiply. If there's nothing above it, we know there's 1. So if we make our table here, how many negative 5s do we have here? Well, we have negative 1. We have 1 negative 5. And we have 6 negative 5s over here. So we can write out 6 negative 5s. And how many negative 5s in total? Well, we have 1, 2, 3, 4, 5, 6, 7. So we have negative 5 to the 7th power. Down here, what we have inside our parentheses is x squared. We know we have 4x squareds, so we can write that 4 times. Now we just need to count up how many x's we have. So here we have 2, so 1, 2. Here we have 2. Here we have 2. And here we have 2. So how many x's we have? 1, 2, 3, 4, 5, 6, 7, 8. So x to the 8th power. Here inside of parentheses we have 2x cubed, or 2x to the 3rd. We have 2 of those, so 2x cubed again. In each of these we have 1, 2, and we have 1, 2, 3 x's. So we're going to count this up separately. How many 2's do we have? Well, we have 2, so 2 squared. Then we have 1, 2, 3, 4, 5, 6 x's, so x to the 6th power. 2 squared we can do, which is 4, times x to the 6th power. Our best answer is 4x to the 6th power. Now over here our brackets are the same thing as parentheses, so inside our brackets we have negative 6 to the 2nd power. So we're going to write negative 6 to the 2nd power, negative 6 squared. We have 3 of those, so we're going to write that 3 times. Now this is telling us how many negative 6's we have. So we have 2 negative 6's in all of these. We'll have 1, 2, 3, 4, 5, 6 negative 6's. So our answer then is negative 6 to the 6th power. Lastly, we are going to find out how many of these we have. So inside our parentheses we have 10x to the 6th power. And we have 2 of those, so we can write that out twice. We also have x squared. We can write that as well. So 10x to the 6th power, we have 10 and 10. We have 6 x's, so 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. And 1, 2. So what we have total is 10 to the 2nd power. And how many x's we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So x to the 14th power. If we wanted to, we could do 10 squared, which is 100, x to the 14th power. Here we have 9xy inside our parentheses, and we have 3 of those. So we're going to write it out 3 times. So we have 9, 9, and 9. 1 9 in each. 1 x in each. And 1 y in each. So in total we have 3 9s, 3 x's, and 3 y's. So 9 to the 3rd, x to the 3rd, y to the 3rd. Lastly, we are going to find the missing exponent. So how we do that is we need to count out how many x's we have. We know we have 6 here, so we can write out 6 x's. We don't know how many we have in the middle, but we know we have 12 over here, so we can write out 12 x's. Now, to find out how many we have in the middle, we're just going to subtract them. So I'm going to take 2 away from here, 2 away from here, 2 here, 2 here, 2 here, and 2 here. What we're left with then is 6 x's, so we know that this has to be 6. So the question mark has to equal 6. Here we need to figure out how many groups of 4 x's do we have. Well, we know we have x to the 4th. And we know that that's 4 x's. We don't know how many groups though we have. We do know in total we have 12 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need to figure out how many groups of 4 x's we have to give us 12. Well, there's 4 x's here, there's 4 x's here, and 4 x's here. So we know that we need 3 groups of 4. So our question mark here is going to equal 3. Lastly, we know that we have 3 z question marks. And we know that each of those we have 1 3. So 3 times 3 times 3 is 27. What we're trying to find out is how many groups of, we have 3 groups of something. How many z's are going to be in each of those 3 groups? Well, 18 divided by 3 then is 6. So we know that in each of these groups we have 6z's. So our question mark here has to equal 6.